So first of all, thank you for the opportunity for me to share my research here with colleagues from other departments. So my focus is kind of quite different from Cheryl's. I focus on children's development, and in particular, I look at how they actually learn math, okay? So why do I focus on math? I would like to cite a study which is a longitudinal study which actually tracked a large sample of over 1,000 children for like over 30 something years. So what they found was that math is more important than we thought. So they found that the math competence at age 7 actually predicts the SES at the age of 42. Even after controlling for some other factors like IQ, something like that. So this explains the importance of math. And I think nowadays when we talk about STEM education a lot of times, we should focus more on math because without math, you can't build the other components like science. In physics, we solve a lot of math problems, etc. So to look at math, I try to use an analytical approach, which I try to divide simple math problems into different components. So this is a very simple math problem. So how do we solve it? be more confident. Okay. So it's 3 plus 4 equals 7. So this is actually not the task that I give you. The task I'm giving you is, what do we need? What kind of knowledge do we need in order to solve these problems? So what do we need to know about before we can solve this problem? What in total means, you need to be able to read, like keywords like in total. What else? Concept of number, very good. We need to know what is 3 and what is 4, how much they represent. Well, that may sound easy for us, but it may be difficult for some children. I will show you some examples. And one final component is that we need to understand the operations. What is addition, what is multiplication, etc. So using this approach, I try to break down math into 3 components: numbers, arithmetic operations, and problem representation. So the last component, problem representation, actually means whether you are able to translate these words into mathematical equations. So again, this may be easy for us, but for students, they may find it difficult, okay? And in fact, most of the research in the field focus on the number component because it's more obvious, but fewer attention has been paid to the other components. So as a first step, I developed new measures to test children's understanding of the remaining 2 components. And this is one of the measures that I have developed. So again, another task for you. So you see the work of 2 students, P and Q. Both completed 3 problems. You only know whether they got it correct or wrong. So both got the first problem correct. The remaining 2 problems, one of them got 1 correct. Each of them got 1 correct. So my question is, which student is able to use more efficient ways to solve math problems? Any thoughts? Student P, why?
Because like it operates on a new element like G plus B, right? It's not like the switch of G and B that quite answer for student Q.
Ah, interesting. Our hypothesis is that actually student Q is able to use more efficient way, but actually you got the rationale because if you know D plus G equals J, G plus D should always be the same as J, right? Because for addition, if you swap the order, it doesn't really matter. So for those who actually aware of this knowledge, they should know that whoa, the student, if they know this principle, they should get it right. So student Q appears to get this, and that's why he or she got it right. Okay? So using this measure, we actually see that children who are able to master this kind of concept, they are actually better at solving math problems. Okay? So this is one of the measures which allow us to focus on a particular aspect of math problem solving. So another math problem. So suppose you have 120 students who need to take a particular course in order to graduate. So you need to organize classes for them. So each class is supposed to be accommodating 15 students. So how many classes do you need if you want to graduate all of them? So this is a simple math problem. But again, the task is not to solve the problem. Which of these diagrams actually match with this word problem better? Diagram A. First of all, do you see the difference between these three? The difference lies in the position of the question mark. B. Why?
Because we need to figure out how many bottles or
Yes. Yes. That's correct. So unit size, number of units, and then you get a total. So now, what you're missing here is the number of units. So B is the correct answer. So this task was developed to assess whether students are able to make sense of the problems, whether they are able to identify their underlying structures. If they are able to identify these structures, maybe they can apply the right solution to the problem, okay? And then they get the right answer, okay? So based on this newly developed measure, we actually show that, for example, these three components all significantly predict math performance. This is a cross-sectional study, and we also have longitudinal evidence suggesting that students who are able to master these concepts, a few years later, their math problem solving is actually better, even after accounting for autoregressor effects. So then I'll shift the focus a little bit to a particular group of students who are very weak in mathematics. So they are suggest to have math learning difficulties, which is actually one of the learning disorder labeled in DSM-5. So they face great difficulties in learning math. I will show you examples. And the problem now is that we actually don't have a formal system for identifying them from schools, okay? So how bad are they in solving math? So this is a grade 1 student. We basically just asked her to write numbers. So you can see I actually don't follow her logic, but 18 becomes 55. And this is another example. I asked them to locate numbers on a number line. So 7 appears here in the range of 0 to 10. That's not the most shocking one. I asked her to count cubes. So this is 100 and this is 1. Guess the answer she has got. She gave 6,000. Why? $100, $200, $300, $400, $500, $600, and then $1,000, $2,000, $3,000, etc. So you see the difficulties that they are facing. So, and imagine they have to go through so many math classes in the future. How are they going to cope with all those? Okay? So because there's no formal assessment system, we are trying to develop such an assessment system so that we develop a screening tool and a standardized assessment tool so that teachers and psychologists can effectively identify them from the system. And knowing that simply identifying them is not enough, we need to provide support to them. So we developed an electronic learning platform, hoping that this e-platform would help them to learn math in a more efficient and fun way. So I probably don't have time to show you the assessment tool, but I would like to show the results. So basically, we validate the assessment tool by collecting data from over 500 students, in which 400 something of them are from a representative sample from Hong Kong. And we do assessment to confirm the MLD status of like 80 students with math learning difficulties, so that we can validate the tool by testing whether the tool actually effectively discriminate between these two groups of students. So the accuracy is very satisfactory. Out of our expectation, the overall accuracy is over 90%, which kind of suggests that it's a very effective way for psychologists to identify students with math learning difficulties. In fact, we are working with the Education Bureau to see if we can incorporate this new assessment system into the education system. Okay? So assessment is just the first part. We need to provide support to them. And one of the interventions that we have developed is to develop some kind of worksheets. They look very simple, but we hope that through these simple worksheets, we introduce the concept of, for example, commutativity, the examples that I just showed you. So the order of operands in an addition actually doesn't matter. So we ask them to do this kind of simple worksheets, and then after solving the problem, we ask them to join the numbers that are identical within each pair. So that we hope that they can see that actually the order of addends actually doesn't matter here, okay? So we use this approach because we want students to discover the principles by themselves instead of telling them directly, okay? We hope that this would help them remember better. And we also develop a e-learning platform with a lot of games so that we hope that students can play the games, enjoy the process, and learn some math skills, okay? So maybe I can briefly show you a video about the e-learning platform.
The electronic mathematics learning platform covers various cognitive concepts related to mathematical achievement. The research team aims to enhance students' mathematical abilities through this cognitive chaining exercise. Some of the cognitive concepts covered by the platform include number sense, place value understanding, and number 9. Number sense refers to the understanding of the relationships between numbers. For example, 8 is larger than 3, and 7 is between 6 and 8. In related games, students quickly judge which number is larger between 3 and 8, or arrange the numbers in ascending order. Such practice helps students understand different relationships between numbers. Place value concepts refer to the understanding of each digit in a multi-digit number. For example, in 231, the digit 2 represents 200, and the digit 3 represents 30. In related games, students practice using the concept of sets. For instance, 10 ones make a 10, and 10 tens make a 100, enabling them to count objects efficiently and understand the quantity representation of each digit in a multi-digit number. In the number 9 game, students are required to accurately place numbers at the appropriate positions on a number 9. The more precise the placements, the better their understanding of numerical magnitude. The online educational math learning platform incorporates various elements that aid learning. First, it provides real-time feedback to players, helping them to improve their performance. Besides, the difficulty level of games is adjusted based on students' performance. For example, in the number 9 game, the targeted numbers increase in value, and the markings on the number 9 disappear gradually. These elements help students to develop their mathematical and cognitive skills within their zone of proximal development.
Okay, so I have demonstrated some of the interventions that our lab has developed, and we are in the process of testing their effectiveness. We hope that we see positive results given the effort that we have put into it. Okay, so towards the end, I will just briefly share with you my future directions. So as you can see, I've developed several measures to assess children's math skills and as well as their cognitive skills. And I'm actually thinking what construct actually underlies this learning process. So in a lot of these tasks, it involves children being able to see patterns, seeing the regularities underlying the problems. So we have been thinking whether it's actually a process of abstraction. So whether you are able to learn something new, you need to abstract the regularities from the problems that you have encountered. So by extracting the gist of the problem, you are able to use the right way to solve the problem. So we come up with this idea, but we are still thinking how to actually assess abstraction using a concrete task. And we are in the process of thinking about it. So if you have any ideas, do come to talk to me. So another future direction is that we have developed a lot of electronic learning platforms, and in the process of playing, there's a lot of data being generated. So how do they actually solve the problem? Did they fail many times, or did they do it use the most efficient way to solve it at the very first time? So this may give us some insights about how do we actually develop our teaching materials so that we can facilitate students' learning. So we hope to analyze the data and hope we can identify some meaningful patterns that predict students' learning in these e-learning platforms. Okay, so that's the end. I would like to thank my students as well as research assistant and other research interns. Without them, all this would not be possible. Okay, so that's all for my presentation.